hand side. The other term that carry the gamma, I throw it to the right hand side like this. Okay, I can arrange the term, and the real equation I can do almost the same thing. But before I simplify this, there are, because this term carry this, so these two equations, the mixture of phi and gamma, I want to get rid of what phi or get rid of gamma. Okay, from the imaginary equation, the phi is only one term, but the gamma has, the lambda has three terms. So that's why I write this. I think of replace whatever the phi that I can see here to this. So there's only one phi term here, but there are so many, how many phi term, phi over z here? One term, two terms. So there are two terms here. But in front, from the imagery, we have this factor, this constant. So that's why every term of this real equation, I multiply with this blue constant. You see everywhere, I multiply with this. Okay, so from here, then you can see that this term, together with this green, I can substitute with this, right? And this term, together with this k gamma, k lambda d phi over dz, I can substitute with this. Okay, I mean to eliminate the d phi over dz. So we have this, is come from here, and then we have this 1, 2. So this term is come from here. Okay, so this one doesn't change, but the blue and the green is substituted by this bracket. So it is just a bit tedious, but the conceptual is not difficult. We managed to eliminate the phi in the real equation. So after this, you just need to open the bracket and simplify. So this is the results after simplification. Okay, and then you have the first order derivative of gamma, now lambda, first order derivative. And then before you do anything, you try to simplify, divide every term with this. So if you divide every term, divide 4k lambda, you have this, constant remain the same. If you divide this term and the k disappear, you left 3 because of divided by 4. This, you have 4 terms here, become 3 terms. K also disappear. And also if you divide with the k lambda, this one lambda disappear. This term solely constant, become really constant. Then we are ready to integrate the whole equation. We integrate this whole equation. So if you integrate this every terms, constant remain the same. This term become ln. This term, these two terms becomes gamma squared after you integrate. This 3 term and this d lambda over dz become gamma whole. This term is a constant. You integrate, you get a z here, and then plus constant of integration. Can you follow? Okay, so after this, you rearrange these results. You rearrange so that you make the ln alone, because the article have the seems that log alone. Okay. So you take the log, no, you divide every terms with this, then you get the log itself. Okay. After this, remember you have the constant of integration. When we integrate, but if you don't want to see the constant, then you can take the limits of integration from 0 to z. Okay. So when you take the limit of constant of the integration from 0 to z, then the constant disappears. So you have this minus this gamma z minus this gamma naught. Okay. So after this, you should get these results. Okay. So this result is not yet applying the limit of integration. This is apply the limit of integration after the limit of integration from 0 to z. So this is the results. And you rearrange in this ln gamma lambda z minus ln lambda 0. You can rearrange into ln lambda z over lambda naught. So the same thing apply to every other terms. Okay, so you can see that these results and the results here, equation 4, are the same. Okay, they are the same. But sometimes he just write like this. It looks different, but they are exactly the same. Okay, exactly the same. Because alpha, he named it as alpha here. Sorry. Okay, but alpha is this. Okay, so they exactly the same. This is the alpha. Okay, and then we have another equation is phi. So for this equation, this equation that we rearrange from the imaginary part, we can look at this one. We simplify first. So that's what I said from that star equation. Just copy paste just now. So if you divide by this constant and the function, because you can see this lambda is on every term, so you can left and right, so you can divide it. Divide with this every term, this will become alone. Okay, equals to something this. So we have this after the division. This become like this, and this become like this. And then you integrate directly. Integrate, and this term become this. This term you integrate, the constant remain the same. This term you integrate, you get the non-lambda. And this term you integrate, you get this lambda z squared. This term, there's no function. You integrate, you get exactly plus a constant of integration. And after this, you apply the limit of z changes from 0 to z. Then